Check. Hello, hello, hello. Are there any Star Wars fans here tonight? Excellent. I already know you're science and beer fans because you're here with us, and that's fantastic. So, we had a pair of scientists that were going to come in and present today. And, you know, I know traffic's bad, but they told me something about having an escort, and it was going to help them through traffic. And, you know what? So they definitely got here safely. And the Dark Lord himself is here. Ladies and gentlemen, the members of the 501st Legion are joining us here tonight. Everyone give them up. And they are here to make sure the talk goes smoothly and safely. Alright, so without any further ado, you guys know Dr. Lisa Will and Professor Shane Haggard, Astrophysicist and Analytical Chemist. And we have a really, really great talk for you tonight, so here we go.
Thank you. Thank you to the 501st again. Please thank them again. Ready for this? I think we're ready. Woo! Ready for this? Hello? That light is like... Hello? I can hear you. Hello? You're on. Okay, there we go. There you go. Alright, so I know we've talked about the worlds of Star Wars before, but let's face it, there's a few more to discuss after last month. Did you all go see The Force Awakens? Yeah! Did you all go see it multiple times? Alright, so happy to be back with you to talk about the worlds of Star Wars, and I thought we'd start the talk with some old favorites, right? So you all recognize the Death Star approaching the gas giant Yavin, where the rebels had a rebel base on one of the moons around this planet, and this is a gas giant, and it is not too dissimilar from what we see in our own solar system. Jupiter, Saturn, Uranus, and Neptune are all examples of what we call gas giants, made mostly of hydrogen and helium, got a ball of rock or ice way down deep in the middle in its core. And when we actually look for planets around other stars, most of the ones that we do see are actually gas giants, these big planets, because they're easier to detect. So it totally makes sense that out in the Star Wars universe, we would see plenty of gas giants. And another famous gas giant was featured in The Empire Strikes Back, where we see Cloud City in Bespin, this beautiful, beautiful Ralph McQuarrie art. We always have to use the Ralph McQuarrie art. And Shane, you want to talk about Cloud City?
Well, what's interesting about Cloud City is when you talk about a gas giant, you kind of have to think a little bit differently than what we think about gases here on the planet Earth. Here on Earth, when you think about all the gases, they all mix very easily together. You know, here on Earth, you know, all the oxygen and nitrogen and argon, they're all evenly mixed here in our very, very thin atmosphere. But when you're talking about things like Jupiter and these other gas giants, that's not exactly the case. You have zones that are more concentrated in one particular gas or another because of temperature and pressure. And Bespin is one of these types of situations. There was this small zone around Bespin that from space down was habitable. And this is where you found the Cloud City. This is where they had the nitrogen, the argon, and the oxygen, and the right temperature and pressure for people to live. Now, of course, here on Earth, it's kind of nice because our whole atmosphere is nicely even distributed. But on these gas giants, you might find these small little zones where the chemistry is just right to inhabit life. But in general, you talk about habitable zones like here on Earth, our gases are all nicely mixed. in what we call a homogeneous mixture, evenly mixed throughout. And so this gas giant, this Bespin here, had one little layer where that worked, and that's where we find the Cloud City.
Could that be real?
So could that be real? Okay, well, let me actually just go back to Jupiter real quick, because, Jupiter's pretty. When you see these different colors, these different stripes that are even easy to see with the backyard telescope, they're actually clouds that are different compositions. The white clouds are made out of different material than the red clouds, than the brown clouds. And actually, if you could feel Jupiter's surface, it would have divots in it, because the white clouds are at higher altitudes than the red clouds are. And so you actually do get these cloud separation layers in these gas giants. Whether or not they'd be like 20-something% oxygen, that's another story. But the cloud separations are definitely possible. They really are. So once again, not too far-fetched. Not too far-fetched. And then this is the forest moon of Endor. But some people think that this foresty place is Endor. No, it's the forest moon of Endor. And Endor itself is a gas giant that's depicted up there in the sky. And so it has this moon that is smaller, not big like a gas giant, and therefore has this sort of lush climate. And in The Force Awakens, we actually were introduced to a couple of more of these types of worlds. There we have Finn and Poe. I tried to get a better picture of Poe, but I don't know. I did try. But I wanted to make sure we could see the backdrop with the planet. And this is Dakar. It is a place where General Leia Organa, thank you.
Yes.
Thank you, is running the Resistance. And this is a small world that if you actually take a look at what's the Star Wars mythology for this world, this had actually been scouted out back during the original movies, right? Back when the rebels were hiding from the Empire to begin with, back when they had basically the rebel base around Yavin. This was one of the planets or moons that they had scoped out to have a rebel base there. And then this is Takodana, where Maz Kanata has her castle. Once again, another one of these beautiful, lush, foresty worlds. And there are a couple of things you need to have a lush, foresty world.
So to have this nice, lush, foresty world, you need an atmosphere that can give you the things you need for photosynthesis, like water and carbon dioxide. So you're looking, when you're talking about having a habitable world, you're talking about the chemistry that will sustain life here. These beautiful forests, we're assuming that they're going to be doing photosynthesis that gives us oxygen to breathe and taking CO2 and using it for fuel and so forth. So when we're talking about the different chemistries, we're still kind of following along with what we expect, in our universe, that we got a planet that's green and lush and water, and it's got an atmosphere to actually support the life in these rebel bases. I think it's interesting, the one before, one of the things about this planet that when they used it was because the life on it was not super intelligent yet. So that was one of the things that when they scouted this planet and chose this planet, was it could support life, but it wasn't super intelligent life yet, so they couldn't be going and telling the Empire where they were at, or the First Order. So I thought that was really interesting when they talked about why they were scouting and chose this particular planet. Still can support life with all that wonderful stuff we need, but it was also kind of primitive at the same time.
Speaking of primitive life, I don't know. So here is a famous image called the Earth at Night. And so you get this whole image of the Earth at night, and what do you notice if you can see the whole Earth at night? What do you see? You see lights, right? And so what I've always thought, so did I hear somebody say, "Where's the sun?" That is a perfectly valid question, because you can't. So basically, when I present this in class, I say, "Hey, can you take this picture all at once?" And the students better say no, because half the Earth's always facing the sun. So this is actually a mosaic of multiple Defense Department satellite images. So you can actually see the whole Earth mapped out to the same resolution at night. And I love looking at it. This is a social scientist's dream. It's a wealth distribution map. It's a population distribution map. There's all sorts of fantastic stuff in here. And what I've noticed is that the Star Wars universe uses planetary nightlights as a way of indicating whether or not a world has what we would call sort of, I don't want to say advanced civilization, but if it has cities and stuff on it, this is the way they show it. So this is Coruscant, the seat of the Empire, what was the seat of the Republic in the original trilogy. And they indicate that this is a seat of power, that this is a place, a wealthy planet, a highly populated planet, by showing the night lights. And this is a planet actually from The Force Awakens that you probably didn't catch the name of. This is Hosnian Prime, because basically the only time we see it was when all the people are looking up at the sky horrified right before the beam from Starkiller Base gets them. Right? And this was the current seat of the Galactic Republic. Now, what I thought was interesting researching not necessarily Earth-like planets, but researching this Hosnian Prime, was that this doesn't mean that it's completely disrupted the Republic, because they were moving around the seat of power. So this was just the temporary seat of power at this time. And we never saw it during the day, but maybe it looked like this. This is an image of our own lovely Earth. And if you look at the Star Wars universe, our heroic planets always look kind of Earth-like. So here is Dagobah, where Yoda lived. This is Alderaan, where Princess Leia was a senator and princess from. And yeah, I know those worlds, especially Alderaan kind of got it. It's not around anymore, but these are our heroic planets.
Poor Alderaan.
This is Naboo, where Queen Amidala was from, where Padme was from. For those of you watching Star Wars Rebels, this is what Lothal looks like from space. And so you'll notice, once again, these are all Earth-like planets. If you're not watching Star Wars Rebels, you should be. Just saying, it's really, really good. And I did want to show a screenshot from Star Wars Rebels, because they also indicated that it's Earth-like in another way. You can see here, as Kanan and Ezra were looking for this particular location, this particular Jedi artifact, you can see Aurora up in the sky, much like you can see Aurora in the sky here on Earth.
Which is a really cool effect and phenomenon. So I don't know how many of you have been to some of my other lectures. One of the first ones I talked about was how atoms and different compounds in the universe, when they get excited by energy, they glow. They give off a color. Some of you who might have an electric stove, who knows what an electric stove is? It's got the metal eyes, or an old space heater. They glow orange, all right? It gives off a color. When you excite atoms, they give off characteristic colors. Our aurora borealis is exactly that. Oops, sorry. You get these atoms up in the upper atmosphere, they're getting bombarded with radiation, with high energy, and then as a result, they glow. They give off this energy back when they release it. So a lot of these things we're seeing here, like these beautiful greens and blues, are all due to the different elements that are up there in the atmosphere. And it's something we can use to actually identify what elements and things are around other planets, and stars, other cosmic events that are going on. It's by looking at the characteristic glow that's giving off when they get excited and release that energy, which is really cool, by the way.
Why do we see auroras over the whole planet? Why do we only see them up near the poles?
All right, so the question was, why do we only see aurora near the poles? And this is a picture that I got from Astronomy Picture of the Day, that wonderful website. And this is aurora featured up near Iceland, because here on Earth, aurora are mainly concentrated near poles. And that's because aurora happen when you have charged particles from the sun, these high energy particles from the sun, interacting with the Earth's magnetic field, and then they get trapped along the magnetic field lines, and they tend to cascade toward where the poles of the magnetic field are, which in our case are located in geographic north and geographic south. And so that's why we see them mostly there. Now, when the sun is in a particularly angry mood, if it has a large explosion, those particles that are ejected from the sun can go even faster, penetrate deeper into the magnetic field, and so you can see aurora from latitudes like San Diego, Phoenix. I saw aurora in Phoenix once. I grew up in Northern California. As a little girl, I saw aurora in Northern California. I was the only person I knew who it was, because that tells you something about me. But But the one in Phoenix was, it glowed red, and so unless you knew what to look for, I was in grad school at Arizona State, and the astronomy grad students, we would do these astronomy open houses and let the public in and look through the telescopes. We saw it because we noticed like there was a big, angry, what we call a coronal mass ejection from the sun several hours previous, and we saw this glow, this red glow low on the northern horizon. We're like, look, that's aurora. For most people, it would have been lost in the city lights. But if you knew what to look for, you can see them from these latitudes when the sun is particularly mad. And like it was pointed out, aurora are usually seen near the polar regions here on Earth. We see them near the poles of Jupiter and Saturn as well. But Jupiter and Saturn don't have these icy poles like the Earth does. And Star Wars does have many icy worlds. This is an Imperial Star Destroyer approaching the planet Hoth. Now, Star Wars gets a lot of people laughing at it because it has a lot of these worlds that just have one climate, the ice planet, the forest planet, and so on. And there, you can get worlds that have one climate. You can. They just have to satisfy some different conditions. So, for example, this world is the 6th planet out in the Hoth system, which means it's far away from its star. The further away from its star you are, the colder it's going to be. If you satisfy the correct temperature for all of the water, for example, to freeze, you're going to have an icy world. In fact, we see icy worlds in our own solar system. This is Europa, one of the largest moons of Jupiter, and it is completely icy. There's a good indication that this is a water ice crust riding on a liquid water ocean underneath. And this is Enceladus, which is a moon of Saturn, which is, once again, a completely icy world, likely riding on an ocean of water underneath. This one actually has geyser activity. We see geysers. It's like amazing. So we get these water geysers coming up. So can you have a single climate world? Well, helps if you're further away from the sun if you want an icy moon. Helps if you're smaller so you don't have big latitude differences to give you very different angles of sunlight coming in. Or it can be atmospheric. The greenhouse effect on the planet Venus is so powerful that Venus has one climate, a nasty one, one that makes it hotter than the planet Mercury, even though it's twice as far away from the sun, and have an atmospheric pressure of 90 Earth atmospheres. So distance, size, and whatever the atmosphere is doing can actually give you a sort of a single climate world. What do you need for ice?
Well, if you want ice, you got to have the right temperature. You also got to have the right pressure. Pressure is also involved. And when you're talking about these ice planets, we're going to be thinking about things besides just water. All right, water here on Earth, it freezes at 0 degrees Celsius. When you start getting out away from the sun, it's getting colder and colder and colder. So you might start experiencing things like, dry ice, solid carbon dioxide, which we can get here on Earth, but it takes a little work for us to do it here on Earth. Really got to lower the pressure, really got to suck out the heat. But this might occur naturally on some of these places. You start getting colder and colder, you might start experiencing things like, nitrogen in the atmosphere becomes liquid nitrogen, and then liquid nitrogen might turn into solid nitrogen, methane. So you are talking about situations where we're not talking about just water anymore freezing. We're talking about the other elements in the atmosphere becoming liquid and freezing and becoming solid. You might have huge just surface covered with like methane or nitrogen, and that's Pluto is nitrogen and methane.
Oh, Pluto has all sorts of weird ices on its surface.
Yeah.
We'll talk about Pluto again soon in the upcoming months. I have not squeezed recently about Pluto at you.
So you're talking about those types of things. And then like on Saturn and some of the other gas giants, where you got the pressure, it might be cold enough and enough pressure that you, instead of getting helium as a gas, you get helium rain instead of helium as a gas. You might even get cold enough and low enough pressure, you actually get helium as a solid, as helium ice. So you're talking about these big worlds that are all solid, but it's not always going to be water. You could be freezing something else that, nitrogen, oxygen, carbon dioxide, all these different elements could be actually part of your solid that you have there on these frozen planets.
I do need to mention the frozen planet that we saw in The Force Awakens, Starkiller Base. I have nothing scientific to say about this one, though. I love the movie, but oh no. So let's go to a planet that we all know and love, which is Tatooine. We got the Rebel blockade runner here. And I still remember seeing Star Wars in the theater in 1977, and this blockade runner was huge. And then that Imperial Star Destroyer came right behind it. It was still the biggest thing I've ever seen. I don't care if they keep trying to make bigger ships. That was still the biggest ship we've ever seen. I know.
I'm getting goosebumps just thinking about it.
I know. So Tatooine, the first planet in the binary Tattoo star system, always reminds me of Mars. This is a picture of Mars taken from the Mars Express spacecraft from the European Space Agency. Got this beautiful low angle, and then I got this really short clip of a flyover of Mars. You're not flying, there we go. And so if I did not tell you this was Mars, if I said, hey, we're flying over Tatooine, you'd just be like, yeah, cool, Tatooine, right? And so, but Mars is not a desert world. Mars is really cold. The reason why Mars looks so dry to you is that the atmospheric pressure is low enough and the temperature is cold enough that all of those things that you would normally think to be liquid or gaseous here are most likely in the ice phase on Mars. And so don't look at that and think like, oh, I need to pack my flip-flops. Nope, you're bundling up. You're bundling up. Really low atmospheric pressure, though, so not strong wind if you saw The Martian. Not strong wind, okay?
No.
So, of course, we have to always do this beautiful, beautiful image. Oh. Can you hear the binary sunset theme in your head when you look at this? All right, so you have Luke being wistful and wishing he was anywhere but there as he was watching the binary sunset. And when we saw Star Wars, that was really amazing, right? And you might think, can you have a world with two stars? And the answer is yes, it's possible. There are lots of binary star systems out there, and we actually do have evidence of planets around other stars. The Kepler spacecraft detected around this particular star system. So what we have here, you have star A labeled as A, and then a second star called labeled as B. And it shows you their sort of two positions, and then that large ring is the orbit of a planet that orbits them both. And it's superimposed on our own solar system to give you a sense of scale. And so basically they both orbit that planet orbit those two stars closer than the Earth orbits the sun, for example. Can that happen? Yes, that can happen. And this is a star about 200 light years away from our own solar system. And these two stars are both smaller than our own sun. And so this is an artist's representation. And I'm thinking definitely influenced by that image of Luke, right? Yeah. Definitely so affected by that. And so you might be wondering, could there be a Luke Skywalker standing on the surface of this planet watching these two suns set? The answer is no, because it's a gas giant, actually. The indications that we have for it is that it's a gaseous world, not a solid world like Tatooine or Jakku, which we saw in The Force Awakens, where we saw Rey looking wistful as the spacecraft left, although for different reasons in that case. Shane, can you live on a desert world like this?
Well, I guess to do that, you would need to have some of the essentials like water. What are they doing to get that water vapor that's there out? They're having to condense it in some way. We can do that here on Earth. We can very easily separate the water vapor outside that's in the atmosphere out and collect it. All we got to do is wait for it to get cold enough at night, put something cold outside, and the water will collect on a nice cold metal surface. Now, in like this situation, it might not get cold enough for that to happen, so they might need some more artificial means to help cool something down to get water vapor to condense. Or, if you're a chemist like me, you go a little more high-tech, and you go find you a nice little chemical sieve, which means it basically is what we call hygroscopic. It takes moisture and just sucks it out. And it catches it in some type of chemical lattice, and then all you got to do is just release the chemical lattice. So to be able to do this, and they talk about moisture farming, they're talking about the moisture evaporators in both Jakku and on Tatooine. I'm thinking they're probably doing something along both scales, all right? These are probably very dry in terms of their humidity, and they probably don't get that cold at night per se. So using just that little dew point thing to evaporate, to condense it might be a little more difficult. But if you use a little bit of chemistry, then you can probably get a lot more water, and it's very valuable. I did think it's very interesting that they did have in the big water trough out for the animal. That's a lot of precious water. But you see in there that they have all this water, and if you read any of the the mythology and the history, moisture farming was actually a very profitable business. All right, to actually be able to farm this moisture. So it's a very cool technology, and if you could do that, you could probably survive in these places.
And when you said chemical sieve, it reminded me, it's not the term we used for it, but remember last fall there was that whole big water on Mars thing? We found liquid water on Mars. That was kind of a chemical sieve because it was the perchlorates, this certain clay-like material in the dirt that was releasing this moisture. I mean, because it really is like, you dump water. The water that we found on Mars in the liquid water form, when you see it, it would just be like damp sand. It wasn't just like you go take a water bottle and fill it up with it or anything like that. And so it was this chemical sieve effect. They don't think it came from aquifers under the surface. They think it was moisture leached from the air by these sorts of chemical sieves. So can we actually see that done naturally then? And the answer is yes.
We do this all the time in the lab. We will actually use certain different chemicals to actually make sure we keep everything dry by sucking all the water out of the environment. We put reagents in a sealed container, put the chemical sieve in there, we suck all the humidity out, and we dry our stuff out. So there's a way to actually do this, and it's, like Lisa said, found perchlorates on Mars. There's water there.
And so I think we've actually managed to cover all of the new planets we saw in The Force Awakens, as well as revisit some old ones. We've been a wonderful audience. I hope you enjoyed the talk, and hopefully we'll come back again and talk about new worlds of Star Wars as we continue to see more. Thank you.
Definitely.
Thank you.
Great job. That was wonderful. Right on. Cool. All right, one more time, everybody. Dr. Lisa Will and Professor Shane Haggard. So they are both two of our regular presenters here and our absolute favorite presenters here. It is not often you get to drink a beer and listen to an astrophysicist and an analytical chemist. That's a mouthful. So if you like this, go to our Facebook page, and the event calendar we have on there is where we list all of our events. And some of them are beer related, and honestly, most of them are science related. But the beer's a given, right? So, but anyway, thanks again so much for coming in tonight, and cheers. Oh, yes, I'm sorry. Our next science talk, Mr. Shane Haggard, February 12th, The Chemistry of Love. You do not want to miss it. All right. Thank you, everyone. Have a good night.